Hi guys, we have a collision problem here. A particle A that has mass of 3m is at rest on a smooth horizontal floor. A particle B, which has a mass of 2m, is moving in a straight line towards A with speed of u meter per second. So the coefficient of restitution in this collision is E here. As a result of the collision, the direction of motion of B is reversed. So I'm going to write VB in this direction. So I expect A to move in this direction. So I'm going to write here VA. So whenever you have this type of problems, you have to know that you can set two sets of equations. One is in relation to coefficient of restitution. Another one is the conservation of momentum. Let's first write the equation that we can set for the conservation of momentum. I choose this direction positive, and then I'm gonna write m1u1, the 3m into its speed, plus 2m into minus u, because in the opposite direction, will be equal to 3m into minus VA plus 2m into VB. So you can see m everywhere, so we can cancel m. Minus 2u will be equal to minus 3VA plus 2VB. This is the first equation we can get. The second one, so we can consider the speed of separation over speed of approach. So when they are getting apart, I can say it will be VA minus VB, so it will be VA plus VB. And when they are getting close to each other, they're approaching each other, the difference in their speed will be u. So I can say VA plus VB here will be E times u. And the other equations that I just got, minus 3VA plus 2VB equals minus 2u. If I solve these two equations simultaneously, I get minus 5VA is equal to minus 2u minus 2EU. And VA comes here, 2 over 5E plus 1U. Similarly, you can get VB as u over 5 3e minus 2. When we look at the second part of the question, you see that the particle A subsequently strikes a smooth vertical wall. So after the collision, the speed of A will be what? 2 over 5u E plus 1. So the wall is perpendicular to the direction of motion of A. The coefficient of restitution between A and the wall is here, E equals 1 over 7. So there is a second collision between A and B. So we need to show that E is greater than 2 over 3 and less than 16 over 90. The bouncing speed VA here will be depending of the coefficient of restitution here. So if I write E equals separation over approach, here will be 1 over 7 will be equal to this bouncing speed over 2 over 5u E plus 1. So we will get 2 over 5u E plus 1 is equal to 7VA. So VA comes 2 over 35u times E plus 1. To have the second collision between A and B, the speed of VA should be greater than VB here, which gives me the idea this is greater than u over 5 3e minus 2. If I cancel this u and this u over here, and simplify this equation by 5 for both sides, 2 over 7 times e plus 1 would be greater than 3e minus 2. 2e plus 2 will be greater than 21e minus 14. So 2 plus 14 would be greater than 19e. 16 is greater than 19e. If we divide both sides by 19, e will be less than 16 by 19. Another thing that we have to consider is that in this collision, the direction of B was reversed, which means the thing that we have chosen for VB, the direction should be positive. So 3e minus 2 over 5 should be positive because that is the direction we have chosen. So if it is moving in that direction, so 3e minus 2 over 5 should be positive. So 3e minus 2 should be positive. 3e is greater than 2, e is greater than 2 over 3. I have two inequalities. If I combine them, e is greater than 2 by 3 and less than 16 by 19, and that will be the answer for this question. Thank you.